So in this example, we're given a circuit that has three sources. We have a voltage source V1, we have a voltage source V2, and we have a current source I1. And we're asked to find the contributions from each source to IX, which is this current here flowing through R3. You notice there's no values given for anything, so we're just going to be setting up equations. And the only way to do that then is to find the equation from each source is to use superposition. So let's see how we go about that. So the first thing we do is we pick one source that we're going to consider. So we'll say we'll consider V1. And remember, when we do superposition, once we pick the source that we're considering, any current sources that other than the one we're considering, we open circuit, and voltage sources other than the one we're considering, we short circuit. So that being the case, this current source then would be open circuited. So it'd be as if it's not there. And then this V2, same thing, we'll remove that, but this time we replace it with a short circuit. So it'll be here. So when we look at this, one thing we notice is we have this V1 in series with this R1. So we can do a source transformation here that will simplify things for us a little bit. So we'll replace that voltage source and resistor with a current source here. Remember, when we do current source transformation, we put it in parallel with the resistor R1, and our value of our current source is V1 over R1. And then we can just come back and replace the rest of the circuit. This was R2, this is R3, and remembering that the current we're interested in is this IX going through R3. So when we look at this, this is just a current divider then, pretty simply. Again, remembering that this part here that I'm showing in blue is transformed to that there. So when we do current transformation, remember we have the resistor that we're interested in, which in this case will be R3, but then we have the branches that we're not interested in. That'll be these two, R1 in parallel with R2. So with that in mind, we should be able to write our equation then for IX from this voltage source. And so that'll be IX, we'll call this IX1. It's going to be equal to the current total current V1 over R1, which we just right there. That's going to be times R1 in parallel with R2. Remember, actually, let me write that with the green so that we can all remember. So R1 in parallel with R2, and then that's going to be over R3 plus, again, the branches that we're not interested in, R2. So now we can expand this and write this out, combine terms. When we do, we're going to have V1 times R2 all over R3 times R1 plus R2 plus R1 times R2. And that's just algebra, plugging these things in. Okay, so that's the contribution from the voltage source. So now we need to come back and reset our circuit. Here, consider another source. All right, so now we want to consider the current source. So that'll be this guy here. So again, remember, when we pick our source, any other voltage sources, we short out. Current sources, we open circuit. So in this case, we have two voltage sources. So we will short both of these guys out. So V1 and V2 will go away. And we replace those with a short circuit. So now this is our new circuit. And so as before, in this case, we don't even have to do a transformation, but we can redraw it to make it a little more easy to see. Again, we have a current source, and this time it's just I1. And then we have R1, we have R2, and again we have R3, again with IX, with this current through here being our IX. So again, this is just a simple current divider. So again, we'll come down here to this spot and write this out. So in this case, IX from our second source, which is going to equal, this time the total current is just I1, right? And that's going to be times R1 parallel with R2 over R3 plus R1 in parallel with R2. So in this case, we'll have I1 times R1, R2 over R3 times R1 plus R2 plus R1 times R2. So you see the R1 wasn't divided out as before, so otherwise it's pretty much the same. Okay, so there's the contribution of IX from our current source. And so finally, we need to consider our third source. So let's reset our circuit again. So here we are. So now we're going to consider V2, contributions from V2. And again, open current sources. So this goes away. And then we short voltage sources. This goes away and gets replaced with a short circuit. Okay, so here we see, we can again redraw this to make it a little simpler. We'll have this voltage source V2, and then that's going to be in series with this R2, and then we'll again have a R2 and R3, again with this being our IX term here. So now in this case, it's a current divider again, but we do have to take into account what the source current is. So in this case, we'll have IX3, that's going to be V2 over R2, and that's going to be times, again, R1 in parallel with R2 over R1 in parallel with R2 plus R3, meter plus R3. And so if we write that out, then that's going to be V2 times R1 over R3 times R1 plus R2, and this will be plus R1, R2. So now we should notice that in each of these cases, the denominators are all exactly the same. So then we should be able to come down here and write the total IX, which we're going to say is IX1 plus IX2 plus IX3 from above. And so when we combine all these terms, since the denominators are the same, we just add the numerators. So it'll be V1 R2 plus I1 R1, R2 plus V2, R1, and again all over this denominator, which is R3 times R1 plus R2 plus R1, R2. So these are the three contributions from each source, and then this is what the total current would be if you were to assign values to everything and plug that in.